Good morning and welcome to the fourth webinar of the China Europe Water Platform webinar series on urban water. Today we are going to have a very interesting program about the carbon footprint of the water sector. I will share my screen now. So. Okay. It should hopefully come to you within a second. It is. So as I said, this is the fourth webinar of a series focusing on urban water. And we have been looking into a number of different topics. On March 16th, we looked at the whole urban water cycle on sponge cities and water in blue-green cities. On March 30th, we looked more specifically on the urban water infrastructure efficiency. On April 29th, we took a look at digitalization, and today we will then look at the carbon footprint of the water sector. So four different angles on the urban water situation, but also four different topics which has revealed a number of similar findings. If you want to dig further into these, all the presentations, recording of the webinars, and a summary report from the previous webinars can be found at the website cwp.eu.waterurban. So please visit that website and have a look. As I said, a number of main findings have been identified, and what we can say within all of these aspects is that a broad range of state-of-the-art solutions exist. Very interesting, very promising, very efficient solutions, but also some where we can see several constraints are hampering the full utilization, efficiency, and scale-up of these. And this conclusion is quite important because the water sector is, well, water sector has, of course, always faced a number of constraints, gaps between demand and supply, pollution, etc. But what we're also facing now with the adding of the climate change is a water sector where we should strive for a much improved situation within this decade. And a much improved situation means that it's both a combination of the incentives for the technology providers, the incentives where policy risks, the uncertainty about when, where, and how regulatory frameworks will take place. These uncertainties must be removed, and a much clear picture of when the regulatory frameworks changes, which will mean that the companies will have much more likelihood of actually investing the money for the water sector. You can imagine companies which have possibilities of their components being delivered to the building sector or industry, and not necessarily the water sector, where we will have water supply, wastewater services, etc. And that the companies will have to choose, and they go for the places where policy risks are low, often all overseen fact by authorities. The authorities also have certain constraints because they are often only having a partial responsibility for the full water cycle. And the sector integration and the full water cycle managed under one roof is a prerequisite for an efficient sector. Also, connected to this is the sector coupling. The water energy, the water food, and the water biodiversity, these nexuses must be combined closer. And this is what we will have a look at, particularly today, where the solutions will cover, in many cases, both water and energy. Very, very relevant for addressing climate change and for adding the water sector's contribution to carbon mitigation. A very promising enabler is from digitalization, and personally, it's my conviction we will not see all the water sector challenges and the SDGs achieved until we get full framework for digitalization. That means data sharing, data access, data platforms, which works for a lot of stakeholders. And we will also have to see that the picture on the economic incentives, pricing, and true cost of ownership becomes much stronger. Today, we have a lot of situations where maybe subsidized prices means that it's the market ends up looking into that it's not pays off to invest into the costly but much more efficient state-of-the-art solutions. And we will have to reverse this picture. We will have to reverse it so that the efforts done in many societies, the efforts done to achieve ambitious national targets, they are also the ones which are reflected when the market requests solutions. And again, another factor we have to look into, the tender designs. They're often based on out-of-date standards. And we will, with today's topic of water and energy, where we will look across two sectors, probably very often see that the tenders only look into one of these and not both of them. So there are a lot of constraints, there are a lot of possibilities, and therefore we will also have a situation with a very interesting program taking this context. We will start with two presentations which will be setting the scene. First, Tia Haavisto from Sweco, which will go through the main findings of a white paper on circular economy of municipal wastewater treatment plants in Europe. And next, Jingjing Ma from Nordic Group in China will look into China carbon neutrality 2030 and 2060 of the wastewater sector. And with these two, we will dig into a number of company presentations. One will be looking into Danish energy neutral solutions to Chinese conditions, and with also looking very much into the perspectives of treating the sludge from wastewater. We will look into energy producing wastewater facilities towards greenhouse gas neutrality made by Danfoss. And we will follow up with two presentations from João Miguero, Vacaro, Portugal, Waterwise Systems, helping water utilities to reduce the carbon footprint, and Riccardo Panciolini from Sierra Unigas from Italy on all burners are no longer the same, a technological breakthrough. Based on these, we will gather for a roundtable where we will look into the topics I mentioned before. And that means those of you who are listening and find interesting topics to be raised, please place your questions in the chat. We will follow and capture these and bring them with us for the roundtable. In the end, the EU SME Centre will give an overview of not only the services offered by the Centre, but also in particular the events which the EU SME Centre and the CWP will organize together at our physical events meeting in real life. Yes, in Aquatech Shanghai on June 3rd. And that's of course mainly for those of you who are already today in China. But we will set up two physical events there, focusing on digitalization and circular economy. And final remark from my side, and I will come back to that under my closing remarks, is again, we will summarize the main findings from today and make these available together with the PPTs and the recording and our website. And we will also put all of these in a cover report, which will summarize the findings from all of the webinars, which we will use in our future work. So without further ado, I will pass on the floor to Tia from Sweco to present the main findings from the white paper made by Sweco. So welcome to the webinar and have a very good joy. Please make use of the chat for all of your comments and questions.
Thank you, and good morning and afternoon. I'm Tia Savolainen from a company called Sweco. I'm located in Finland, and I'm here to talk about the white paper we wrote for China Europe Water Platform. It's called Circular Economy of Municipal Wastewater Treatment Plants in Europe. But first, let me introduce Sweco to you. Sweco is Europe's leading engineering consultancy with almost 1,800 employees and a net sales worth of 2 billion euros. We have offices in 14 countries, and we carry out projects in 70 countries annually around the world. Here you can see our main areas of expertise. They are architecture and urban planning, expert services for renovation and construction, structural engineering, industry and energy, infrastructure, project and construction management, building services, and water and environment, which I'm representing here. And now to the main subject. Here's an introduction to the white paper and circular economy. The white paper discusses a circular economy of municipal wastewater treatment plants in Europe. We focused on the implications of circular economy concepts on wastewater treatment plants, including wastewater treatment, in energy capturing, nutrient recovery, material reuse, and material efficiency. New partnerships and business models too. The white paper is a base for discussion on the future of circular economy of wastewater treatment. We try to start a discussion on what the wastewater treatment sector will look like in the future and create opportunities for cooperation in business policy and research. The paper includes a short overview of past developments and the current situation, with a focus on innovations and technologies which are likely to be widely applied in the future. The paper covers only Europe and considers the general situation on the continent, and it includes examples from European countries and examples of possible emerging technologies. Then a short introduction to circular economy. Well, it's a systemic approach in which the waste is minimized and life cycle value of natural resources and products is maximized. On contrary to linear take, make, and waste model, circular economy approach is based on the principle of reduce, reuse, recycle, restore, and recover, so-called 5 Rs. And many resources like energy, water, materials, data, know-how, and value creation could be circular. Water has a global natural hydrological cycle, and the circular economy of wastewater is in fact circular economy of water. And circular economy, in circular economy, water is used efficiently, minimizing its loss. Substances dissolved in the water during its use and the bound energy, they are recovered and returned to the circulation. This is achieved by using less fresh water and reusing the water upstream. Because from a more concentrated wastewater, nutrients and materials can be recovered, and the wastewater treatment plants needed are smaller. After collecting the valuables from the wastewater, it can be reused as industrial or even drinking water energy recovered from wastewater can be used in wastewater treatment plants, and the surplus could be sold to energy networks. And now I'll tell you about the current situation of circular economy in wastewater treatment plants in Europe. First, about ecosystems and business models. Circular economy is built on business models and ecosystems where operators are interlinked. Here are some examples from Europe. Well, most of the wastewater treatment plants are owned by municipalities or public actors in Europe. In Sweden, there's a low hierarchy model in which an individual becomes a member of the company when the individual joins the water supply network. And in Netherlands, wastewater treatment plants are seen as energy and resource factories. In the Dutch model, the water authorities and their umbrella organization, the Foundation for Applied Water Research, and several knowledge institutes and many other organizations, they are joined together. They support and guide governance and circular economy. In the Nordic countries, municipalities have utilized the model of industrial and urban symbiosis, where they support each other, and also a model where multiple municipal wastewater treatment plant sludges, they are collected and processed by a private company. It is an option. And the sponge city aspect, developed and widely applied in China, has become popular in Europe. And then about energy recovery. Well, the wastewater treatment plants should be viewed as energy and resource factories, as in Netherlands, as they have a great potential. Energy capturing methods here, they include, in example, biogas plants that produce biogas from wastewater treatment, plant sludges with or without thermal hydrolysis or co-fermentation, and heat recovery from compressed air, from aeration, wastewater or effluent, and coupling of district heating or cooling from the water and wastewater networks. Anaerobic digestion as an energy source at wastewater treatment plants is getting more common every day in the Nordic countries. And heat recovery from wastewater, it is applied in Central Europe, but also in the Nordics. Here's a picture of Helsinki area's heat recovery from wastewater. In Germany, solar drying, low thermal drying, and hybrid systems are used for sludge drying. And in Netherlands, their specialty is decentralized heat recovery called radiothermy, gasless energy. Radiothermy is a technique for recovering energy from wastewater from the sewage system via heat exchangers. And then about resource recovery and efficiency. Here are some examples of resources that are recovered from European wastewaters. They are nutrients such as phosphorus and nitrogen, and they are used in agriculture. Metals, carbon dioxide, alginate, as in this picture, proteins, and also cellulose. And of course, water can be reused. And then to the future. Here I'll present you some future scenarios that were created during workshop with Sweco's European specialists. Here are examples of subgroups of future technologies that were noted in the workshop. I could make some examples from here, such as, well, of course, reuse of water, new power solutions, integrated and new approaches, and also climate change. advanced wastewater treatment, decentralization, modeling, also source separation and new ecosystems, scalable technology, and also process optimization. And here are the conclusions of the white paper. So there are currently several projects in Europe that seek to develop the circular economy through holistic ecosystem thinking and cooperation. As primary sources become scarcer, resource utilization from wastewater has become an increasingly profitable option. Water reuse and recycling are important, especially in countries where freshwater resources are scarce. In Europe, developments will continue in the future. New holistic communities will be formed to recycle energy and resources instead of wastewater treatment. The wastewater treatment plants are seen as energy and resource factories. Technologies for implementing these exist in Europe already, and now mind chains and holistic concepts for their management and best use will be required. And the future of the circular economy in Europe is not possible without digitalization and artificial intelligence. In the future, artificial intelligence will use the process and environmental parameters to predict how the processes of a wastewater treatment plant should be run in order to control the predicted event in the coming days in the future. In the future, Europe can offer China concept and package solutions focused on holistic management, where the result is better than the sum of its parts. The new big cities offer huge opportunities for the introduction of a holistic and controlled circular economy system. Thank you for listening. This was my presentation.
Thank you, Tia. I actually have two questions for you now. One of them is, you mentioned that in Netherlands, the wastewater treatment plants were organized as part of energy plants.
Yes.
Is it your opinion that the regulation in Netherlands is ahead of other countries? And connected, do you see any impact from EU regulation on moving this entire water energy nexus forward?
Yes, our team in the writing process of the white paper, we saw it as a huge opportunity to couple these two, energy and wastewater treatment and the mind chains. It would support the future of circular economy of wastewater treatment plants.
And when you look at the regulation, do you see differences worth noting between the European countries, some countries being ahead?
Personally, I would like the Dutch model because it seems an effective one. And the regulation, at least in Finland, as far as I know, is guiding towards that.
Also in your conclusions, you remarked that mind change and holistic concepts were needed. What can you extend that a bit?
At the moment, people seem to just forget about wastewater treatment and think it as something that must be done, something that is related to wastes, and something that people want to forget. They don't see the full potential of producing energy and thinking big, so to say.
Okay, thank you very much, Tia, and to the knowledge of everybody, the white paper developed by Sweco for our colleagues at the ELI Center in Turku in Finland as part of the CWP program will be available at the CWP website together with the PPTs from this webinar. Now I would like to bring Jingjing Ma from Nordic Group China to the floor, and Jingjing Ma has taken a look at carbon neutrality in the wastewater sector and energy sector in China. So please, Jingjing.
Thank you very much, Eric. And can you see my screen?
Yeah, just need to put in presenters mode.
Yeah. Yes, good morning, everyone. I'm the CEO of Nordic China, and today we are very glad to share our insights on the Chinese carbon neutrality national targets on the wastewater sector. And firstly, I will just brief about the Nordic, because for some people it may be a new name. Nordic Group, we are a young company, 6 years old. We are 50 staffs right now in Denmark, in China, in Beijing, and we provide strategic advice to the government, city mayors from the master plan, conceptual master plan, and sustainable buildings, and also the wastewater solutions based on the Danish technologies mostly. Today, I'm going to brief about the Chinese latest national target on the maybe all of you have been heard the carbon peaking and the carbon neutrality 2030 and 2060 target. And we are going to sharing about the last 10 years Chinese water sectors, about the carbon footprint, and we're going to elaborate on the potential on the urban wastewater industries technologies in China, and also the opportunities for Danish technology suppliers. And then lastly, we are going to also sharing our insights on from the wastewater treatment plant concept to the energy recovering plant for China as an overall trend as well. For the Chinese last 20 years, we have been also working intensively on the international UN framework on the climate change. And last September, our president, Xi Jinping, has been officially announced Chinese national target to achieve the carbon neutrality. And also we have been doubled our non-fossil fuel primary energy consumption, and also tripled our national forest stock volumes by 2030 on the carbon sink strategy. And lastly, also our wind and solar power has been doubled since the latest version announced in 2015. This means a lot for the overall Chinese energy structure and also the water structure, green transition. And for the latest release, the 14th five-year plan for the China and also the 2035 national target, we can see that the National Energy Ministry has been called for public comments of the 14th five-year plan renewable energy enforcement, lay out the 7 priorities as the guaranteed energy securities, also the emphasis on the green and low carbon development supports Chinese pledge to the peaking CO2 emissions before 2030. And also the focus on the coordination on the energy, 7 energy regions, and also the encourage propose on the market-oriented reforms. And also last one is enforcement of the international cooperation. This is a very critical map for us to get started. We know that by the 1.5 degree target, based on the simulations, Chinese, we are going to have our carbon peak, which will be around 12 billion CO2 equivalent by 2030. And then we are going to achieve the carbon neutrality by 2060. And right now, to achieving the 1.5 degree target will require additional green investment for around 138 trillion RMB. And which is around 2.5% of our GDP per year for the next 40 years. And also to achieve the China-Europe Green Deal climate target emission reduction by 50 to 55% by 2030. This is also annual investment for the 260 billion euros, which is 1.5 GDP of the 2018. There are 7 major green investment sectors based on this 138 trillion investment. And as we can see here, they are from the renewable energy utilization to the end consumption side electrification, to the zero carbon power technology and energy storage, hydrogen, energy efficiency, and digitization. So today we are going to focus on this 11 trillion RMB market on energy efficiency. That's mostly what is wastewater sector covers the potential for the upgrading of the existing infrastructure. Something about the Chinese wastewater sector's carbon footprint. Based on the WRI, the greenhouse gas emission protocols, we can see that mostly the two direct and indirect emissions from the wastewater process, from the wastewater inlet, from the treatment process emissions, and also the sludge treatment emissions. And also like the leakages from the wastewater transmission, and also like the transportation of the waste disposal requires the proposed indirect carbon emissions of the carbon footprint circle. We also have done a lot of research for the back from the 2001 to now, in the last 20 years, how the Chinese direct emissions and indirect emissions from the wastewater sector. And this is the latest number we can get, and the analysis by 2015, we can see that mostly we separate China into 5 regions: South, East, Northeast, North, and Northwest. Mostly based on the climate zones, because China is, we have covering 5 climate zones. And for each climate zones, we have a different kind of wastewater technologies, which requires different kind of the carbon emissions. So roughly we have, we can see here for the 5 major regions, the highest carbon emissions actually is from the North China and also the Northwest China, because of the cold climate in the winter time, and also we need a lot of aerations in the MBR process, which is mostly Chinese wastewater treatment plant applying for. And then for the South China, because of the warm climate and also like better efficiency for the aerations and also less intensity on the sludge production. So we can see that it's almost 50% less compared with like in North China wastewater carbon footprint intensity per cubic meter. We also had a calculation about in the last, from 2007 to now, what is the total greenhouse emissions of the wastewater treatment plant for China. And we can see that in terms of unit power consumption per cubic meter is increasing from the 0.25 kilowatt hour to 0.314 kilowatt hour. So it has been like slowly increasing. And also we can see the total greenhouse gas also has been increased from almost 8.4 to 50.28. So we can see also that in the last 12 years, Chinese, in terms of numbers and also the greenhouse gas emissions from the wastewater has been 6 times increase in the last 12 years. So meaning that we have a 50% of the increasement per year. That's a very big increase, steep increase. And we also can see from the indirect greenhouse gas components from the wastewater treatment plant is mostly consists of the five components. Mostly are like the drying the sludge and also the mechanical dehydration consists of 27%. And then we have aerobic fermentation, which take 18%, and also the aerobic digestion. So heavily the sludge-based wastewater treatment plant requiring a lot of treatment for the electricity. And this is analysis for in the 13th five-year plan, last 5 years, how the urban dry sludge production and also the disposal status. And a lot of you maybe know that only until 2015, China will start to a treatment of the sludge. Before it's only like landfill disposal. And right now, no matter from the landfill disposal amount and also like the water rate has been heavily enforced by the local EPB. This is the trend for the wastewater sector in the last 10 years, and we can also say mostly in the urban sector there is a huge growth from the 2010 to the 2020, and we also can find that actually Chinese urban wastewater infrastructure investment has been heavily under the Chinese national water policies, as we can see here. When there is a state-owned policy encouraging the water sector, then we have a huge growth on the urban wastewater treatment investment. And this is the power consumption analysis based on the different regions. We also have analysis on from the Sichuan province has the highest amount of the wastewater treatment plants, and like the Shanghai has the lowest one. But mostly China, we have in the big cities the 10,000 wastewater treatment plant, they got the water discharge permit, and 97% of these 10,000 they have to release their pollutant amount and also the emissions concentration of their discharge. And we can also see that the wastewater treatment amount, which is lower than 50,000, they have mostly 34%. And then the smaller wastewater treatment plant, like like from 10,000 daily treatment from 10,000 to 5,000, they have roughly 25%. And around 10,000 daily treatment amount, they count for half of the total wastewater treatment scale. This is the CO2. This is the carbon emissions we calculate based on the previously numbers in the last 10-15 years, and then we calculate that roughly 54 million CO2 equivalent back to 19 has been emitted to the air, and that's count around 0.5% of the Chinese total emissions. And we can also see forecast that due to the rural development in the next 10 years, we can foresee that will be similar trends for the urban development in the last 12 years. And by post-30s, that will be around 2030 to 2040, based on the 1.5 degree scenarios. We have to achieve around 50% to 55% of the emission reductions, and then finally by 2050 we have to reduce 70% of the greenhouse gas. That's based on the latest national target. Finally, we would like to also share that there is a quite huge gap between the rural wastewater treatment scale and also the urban wastewater treatment scale. By 2019, from the rural China, there are less than 40% of the rural wastewater generated from the rural China has been treated. And for the urban China, the treatment rate now is close to 95%. So this is quite obviously that we can see the rural scale, county level and village level decentralized wastewater treatment plant will be built dramatically in the 14th five-year plan and 15th five-year plan by 2030. And this will be also the emissions from mostly from emission increase from the rural wastewater facilities. Yeah. Upon the final one, that we think the improvement of the water quality and the wastewater treatment rate accelerate the emissions of the greenhouse gas during the wastewater treatment process, and definitely that the rural wastewater treatment sector, which will be increased a lot for the next 10 years, cannot be ignored. Yeah. So this is mostly our. Thank you.
Thank you very much, Jingjing Ma, for this comprehensive presentation where each of the slides could deserve in-depth discussions. Again, as stated before, I think you should stop sharing now, Jingjing. This report will be also available at the website afterwards. Just one question, Jingjing. The speed of investments in rural wastewater treatment plants is very high, and at the same time you also showed that the energy use per cubic meter is still very high. So we are quite far from a situation where we will see the wastewater sector as an energy provider. It's still an energy user.
Yeah, this is what we also found after finding a lot of analysis and the interviews. First one, it's a bit difficult for us to get a direct power consumption per unit wastewater, no matter where. So we have to combine a lot of data and make our own consumptions about the treatment, and then also like make the calculations afterwards. But the trends, it's quite, for sure, we have deep growth of the trends. We have really deep growth for the energy consumption per unit cubic water in urban areas. So this is what we think for. We also can foresee that in the rural treatment as the same, like we call the 2.0, version 2.0, probably they will have the similar growth trend both in terms of scale and unit power consumption. We also trying to find some case studies for the energy recovery plant, but that's like really like not so much. So that's why we can't say that this has become a trend yet. Maybe in 5 years, in 8 years, it might be people will thinking about how to recover the energy from the existing wastewater treatment plant. But right now, if we talk about, let's see, 10 plants out of 10,000, I think it's not represent the trends. Yeah, but I think this is because Europe is doing that in the last 20, 15 years. So we can see this is a beneficiary, but it takes time, I think, to see the change. Yeah.
Yeah. Okay, Jingjing Ma, we will come back to you and your findings when we get to the roundtable discussions in the end. So thank you very much for your comprehensive presentation. As always, a pleasure. Now I would like to pass on the floor to Jingchuan Lu from the Danish Export Association, who will be talking also about his organization's efforts to try to promote state-of-the-art solutions. Please, Jingchuan Lu.
对不起啊，尊敬的各位嘉宾，大家好，我是来自丹麦出口协会的吕清泉。我今天向大家报告的题目是如何使丹麦的能源综合解决方案适合中国的国情。我的报告分2部分，我将首先介绍丹麦污水厂能源综合解决方案，然后介绍我们丹麦出口协会为促进中丹2国在该领域的合作正在进行的工作。丹麦的污水处理技术非常先进，丹麦基本上实现了污水处理的智慧化管控。举个例子南丹麦水务公司负责2座城市、8座污水处理厂和20多个污水泵站的运营，但所有这些污水厂站全部由安装在一台电脑中的一套软件程序自动调节和运行。这1名员工在上班时间来负责排除来自设备的故障预警，全部污水厂的设备和泵站的设备都实现了智能控制。我觉得我这个 PPT 有点问题我怎么看不到我的第4页？那么今天我在讲，接着往下讲吧。我第4页看不到那么丹麦呢？我们今天讲这个碳中和。丹麦在巴黎协议之后制定了本国的气候行动计划，有了自己的3050气候目标，是能源综合和气候综合的重要组成部分据我们出口协会调查的结果呢，丹麦至少有8座污水厂实现了能源综合，而根据丹麦给排水协会的统计呢，丹麦共有74座污水处理厂有污泥的厌氧消化，他们的平均能源自给率呢已经达到了91.7%到饮用水生产水出水管线的能耗以及小型污水厂能耗呢，丹麦水行业的能源综合工作仍然是任重道远的那么我现在跟大家解释一下，丹麦的污水厂是怎样实现能源综合的。在这里我还拿丹麦的一个污水厂叫埃比米勒污水厂向大家分享一下。这座污水厂呢的规模是5万吨每天，它的生化部分是典型的 AO 工艺，但历经了10多年的升级改造呢，在2020年达到了能源综合自给率达到了212%的水平这里呢它是没有引进外来的生物质进行协同消化来达到这个标准的。出水水质也相当好，能够满足咱们国家 EGA 的排放标准，而去除氮的过程呢是没有外加碳源的条件下实现的。那么它是怎么实现的呢？总结起来它有以下5个措施第一个是修缮了 管网和泵站，提高了污水的收集率，这呢有助于保障污水中的有机质的含量。二是呢，提高了这个机械处理效率，使该厂的隔山、隔油、除沙和初级沉淀呢都有很好的效果。在进入生化之前，有5%的机制被分类出来去做厌氧消化，生产能源，同时呢又降低了生化池的爆气能耗。三是采用了能效较高的设备，从而降低了运行能耗。四是优化了污泥的厌氧消化工艺，提高了污泥的产区率。同时呢，侧流厌氧化的应用呢，又大大降低了脱氮的能耗。第五呢，也是最重要的一点，该厂的生化部分借助实时监控数据的采集呢，在数字孪生程序的控制下，实现了短程脱氮，大大降低了脱氮的能耗。那么我们现在正在执行的项目呢，是中丹水务合作项目，叫 EU SME Water， 由丹麦工业基金会资助。这个项目的宗旨呢是联合丹麦的水技术公司与中国水务公司合作，将丹麦已经得到的技术成果呢应用到中国，促进中国水务领域的节能减排，助力中国3060碳减排目标的实现。但我们也知道啊，这个中国污水厂的水质、工艺路线和处理规模啊，可能跟丹麦的会有很大的不同啊。因此呢，丹麦的解决方案必须按照中国的国情做因地制宜的适应性改造，才能够在中国得到应用。目前呢，我们正在积极的与中国的水务公司做技术交流。今年1月份，我们同国内的5家水务公司分别举办了技术研讨会。从下周开始呢，我们将继续同国内的另外5家公司举办技术研讨会。通过技术交流啊，这个我们呢，根据中方的提出的需求呢，现在已经整合出了5个技术包。我们的目标呢是在2年内组织丹麦的技术公司同中国的公司合作，在中国发起5个示范项目。同时我们也注意到啊，有些丹麦的中小企业尚未进入中国，但其技术和设备呢，对形成丹麦的解决方案又是必不可少的。因此啊，我们工作的另一个重点呢，是帮助丹麦的这些中小企业在中国找到合作伙伴，实现其产品的本地化生产和售后服务。这是我们正在做的工作。那么，如果你想了解更多关于丹麦污水厂能源综合解决方案的信息，或者有兴趣与丹麦合作，那就欢迎你跟我们联系啊。这个呢是我们的联系方式。那么我这个 PPT 啊，播放有点问题，今天啊，我就暂时做到这里啊。谢谢大家。So I have finished my presentation.
Thank you very much, Jingchuan Lu, for your presentation. You mentioned that you have been in touch with a number of Chinese water companies or large utilities. Have you made any analysis of what it would take for your organization to go for tenders, for standard tenders, or do you only go for high-end market part of the market?
Our strategy is to organize the Danish company together as a consortium from Denmark to work with large water companies to provide a total solution. We have worked with communication with them, but we haven't reached a stage of building our real project. But it's our plan to make a demonstration project together with these Chinese water companies.
Okay, thank you very much. So, do you consider that these high-end utilities have have a better better situation in in promoting the use of state-of-the-art solutions?
Yes, I do think so. When we have a meeting, they are looking forward to work with us. We have very good discussion. After workshops, after last visit, we keep on contact with them. We are about to visit them again in next week in Beijing, Shanghai, and Shenzhen.
Okay, good luck with your efforts. I think your efforts is an illustration of how much organizational capacity it takes to actually promote the entrance of particularly small medium enterprises into coming from Europe into a market as the Chinese. It really takes a strong organization backing these efforts. So good luck with that, Jing-Chuan Lu.
Thank you very much. Thank you.
Okay. Bye-bye. And now I would like to pass on the floor to Mads Warming from Danfoss company. Mads, please take the floor.
Yep, thank you. Somebody open so I can get the camera on. Hello?
Hello, how can I close my share of screen?
Just the red button.
Yes, it's done now. All right, simply leave for a while.
I can still not get access. So then it helps. Can you see my screen?
Yes.
Super. Yes, and thank you for the invitation to make a short speech here. I will try to keep it within the 8 minutes, which Henrik is looking for. What I will talk about is ND producing wastewater facilities and also the journey towards greenhouse gas neutrality. And it's on purpose not carbon neutrality, because that's not the same. It's about greenhouse gases as such. I'm coming from the company Danfoss, and will only spend one slide, very shortly talk a little bit about who is Danfoss. Major company represented globally, but with headquarters in Denmark, around about 28,000 people. And of these 28,000, if I recall right, the latest figure is around about 5,000 people in China, which you'll see in the mid picture here, one of the Chinese factories we have there. So an international company. And without diving too much or spending too much time on that, one of the divisions at Danfoss is doing what we are calling variable speed drives, which basically is an electronic unit, which means that you can begin to regulate on motors, on blowers and mixers, and all the equipment you have on the water in the water industry. And the reason that it is so important to have that capability, controllability, is basically that exactly the water industry is different to more or less all industries in the way that the load on the facilities is jumping up and down during 24 hours, as are down on 10-20% during nighttime and at peak in the morning and the afternoon. Therefore, it means so much whether you have the capability to regulate or not. I will again not deep dive into a variable speed drive, but one of the few things adding that type of equipment, you'll get this controllability. But besides that, you'll get a tremendous lot of energy saving just reducing the speed on a pump with 20% will offer you a typical 45% energy saving. So there's something to gain. But there's a lot more to the story than that. So that was enough about Danfoss. International Energy Agency, which I guess some of you know of, we have been working a lot with over time and had a close cooperation with. They have estimated, in fact, how much energy is the water industry using globally, and the figure is around about 4% of all electricity used globally. That is for the water industry. That's equivalent to all the electricity being used in Russia. The other thing I think is interesting is that if a municipality want to do something to contribute to reducing the carbon footprint or the use of energy, then the water and wastewater facilities typically use 30 to 50% of the municipality's electricity bill, and is typical a factor 6 more energy intensive than the lighting in the streets, just to put it a little bit in perspective. In 2018, IEA also looked into the new Sdg Goals, and the new Sdg Goals is aiming at that we globally should go from 20% of the wastewater being treated to up to 60% within 2030. Now, seen from an energy point of view, that's maybe not the best thing, because that would mean, as we already have heard, a use of a lot more electricity. What they then also tried to investigate was that, yes, that's true, but what now if we do it a little bit more clever? And the way they looked at it was that they were visiting the case I will show you, which is Aarhus Water, and looking at that if everybody operated their wastewater facility the way they do in Aarhus, what would the difference then be? And the end of that story is that the difference would be 650 terawatts, which not say anything a lot. But if I now tell that the savings would be equivalent to all the energy coming out of all coal power plants in Europe, then we put it a little bit in perspective that this can be a major contributor. So to the specific case where we go 5 years back, where the Mercedes-Benz era covering 200,000 people, I guess it was the first place on the planet where we both have water supply to 200,000 people and wastewater treatment basically without using energy or being in an energy neutral case. And what is super important is there's not used any wind, solar, heat pumps, sludge from other facilities, anything from the food industry. There's no sludge burning, there's nothing. There's basically just household wastewater, no tricks, but advanced control of the facility. So the good thing about that is that because of that, it's possible to copy what have been done. If we look at the data where we have 2016, 2018, I can tell that the 2020 figures is looking a little bit better than the 2008. We have not got them totally confirmed yet, but it's in the same ball game. So let me very fast run through. They spent 3.2 million on supplying drinking water, 0.8 on wastewater transport. They spent 3.2 million kilowatts on treating the wastewater, and you can see the level in the effluent here. So totally 7.2. They were able to generate 4.8 million in electricity production, 2.6 million surplus of heat. So in total, 7.4 million. And that means that now we have in fact more energy than we need, not only to treat the wastewater, but also to provide for the drinking water side. And that means that when that facility was up peaking, it was producing 234% of energy. If you cannot use the heat, which is the case some places, then at least you can use the electricity, and which is up to 150% here. What I also think is super important to understand is that this is not a new facility. It's an old facility. It's a 30, 40 years old facility. So it has nothing to do with that you have to rebuild the whole thing or build a completely new. It is a little bit back to what Henrik said in his introduction. It's a question about digitalization. It's a question about optimizing the facility. So it's a very traditional activated sludge treatment plants. There's not a lot of special things on it. The digester is the same as we normally see. There's a little bit on reject water. I'll come back to that, but else not. What have they basically done? They have installed a tremendous lot of sensors, which you normally not see, and they also trust the sensors to a level that they let the computer control everything. And there's a trick to how you can get into that position, which we maybe can take at another time. The other thing is that there is variable speed drive on everything which can move, so they have full controllability. They are looking very much into what we call carbon harvesting. That means to take really the energy out in the primary sedimentation. They of course use highly efficient components. There's process know-how, which is pretty deep, but which you basically only really can use if you have this controllability. So having all the sensors, which is the digitalization part, to have all these sensors, understand how to connect them, and really utilizing them, and then using the variable speed drive for process control. So I will not deep dive. The time is not to that into the process part of it, but we can do that again if somebody have interest in it. Then of course combined heat and power installation, so that you both out of the digested gas get both electricity and heat. What they are looking at right now is, as I said, that in the water industry, it's not only a question about being energy neutral. That's the first step, but there's also N2O, which is a gas which have a effect on the CO2, which is 300 times higher. And if you really want to be climate neutral, you need to have that into your perspective also. And that they are looking at right now. There's also an issue about sludge disposal. So they hope that this year, in fact, will be climate neutral also, including these gases. Even though the experience in Denmark is that, and also globally, that these gases in fact affect more than a lot of people have thought if you just go 3 or 4 years back. If we have done, then as I mentioned, then a lot about real-time sensors where they trust them fully. A lot about controllability, which the variable speed drive can offer. A lot about advanced process control, and then efficient components. But what is important, not only from this case, but also from the Odense case we just heard about, and also from Copenhagen, and we have begin to have similar things in Chicago and other places. But at least from these three, that if you ask the process people and the guys which have been working with this, what really have moved something, then it is automatization. The 70% is in fact automatization or digitalization which have moved something. Yeah. A couple of innovation awards and also reflection from the European Center in Brussels that this is the prime case in Europe, and some other awards which we have got. And I think the final thing I will say in this short time here is that besides what I have been talking, making it climate energy neutral, all that was based on the biological part. What we see also coming up very fast, both in Denmark, in Sweden, other places, is to utilize also the heat. And that's what you see down in the picture down here. And what you see here is, in fact, a picture I have borrowed from Rumble, which say that if you want to make sustainable cities, then your energy network will be based on a tremendous lot of resources. And they have not because of our, they have themselves included water and wastewater as a part of the future energy network of a sustainable city. And I think that's what we'll see. That about heat pumps, the calculation in Denmark tell that basically using heat pumps on outlet from wastewater facilities will be able to heat 20% of all houses in Denmark. I think that was the words within the pretty short time. Yeah.
Thank you very much, Mads, for this fast forward presentation of the results, impressive results from, in particular, the Marselisborg plant in Aarhus. Very, very impressive. A couple of questions. First of all, you said in the beginning that the wastewater treatment sector roughly takes up 4% of global carbon emissions, something like that.
No,
electricity production use. Yeah. Which again, of course, corresponds to a nice share of the global CO2 emissions. If we also add that that when it becomes resource recovery plants, we could also add a share of a contribution to climate change here. Now, as the entire discussion about climate change mitigation is also a discussion about acting fast, how would you place the water and the wastewater sector in line with other possibilities for achieving CO2 mitigation? Are we among the sectors who could actually deliver very fast if we wanted to, or are we the ones who might only get the results further down the road? And I'm particularly placed this question, of course, with an intention, because you also said that the wastewater treatment plant where the result was derived from was not a new one. It was actually an old one, but based on a huge improvement of management and operations. So it's a leading question. Over to you.
It is a leading question. So I think if you take it from a technology point of view, and I think you also said that in the introduction, what this show is that the technology is there, we know what to do and how to do it. Having said that, we also have to, whether it sounds a little bit rude, to accept that the water sector is a monopolistic sector. So if there's no regulation, then there's not always the needed pressure on doing something, and that's what we see. As we have dealt a lot with the US, we have dealt a lot with a lot of countries around the globe, and there's a high interest, but the implementation rate is not really there. And I think, and you probably also know that the Danish government now have set the goal that in 2030, the whole Danish water sector, both water supply, wastewater, small plants, big plants, have to be complete energy and carbon neutral. And the purpose of that is, in fact, that I think it's right that the government have to set these ambitions. That can then be done in different ways. And we can, the good thing is that we can see that Brussels is picking up. So in the revision of the wastewater directive, they are beginning to discuss now that the task is not only to treat water. Of course, that's the most important task. But as the technology is there, that you can treat the water, provide water, treat the wastewater without using energy and thereby contribute to the climate mitigation, then you also have to do it. And it's not confirmed yet, but at least it is in all the discussions down in Brussels going on, that they want to move that way. And I think that is, to coming back to your leading question, that is in fact what will move it forward. Of course, there will be a few utilities here and there which have a management who really want to be in front and so on, and that's fine, and they will do. But if we want really to contribute, then I think it's Brussels and that type of things which will move. And then to your question, when I mentioned this about, and I think in China it's especially important, this about also utilizing heat pumps, then we are not talking about a sector being climate neutral. We are talking about a sector really contributing massive to the climate mitigation, because suddenly coming into a position where the water sector can heat 20% of the houses in Denmark. Now you're moving something. The precondition is, of course, that you have a district heating system. But I know in China, there's at least quite a lot of places where they have district heating systems. So where they have that, that's a great opportunity. And it's the most efficient way to have a heat pump because you get a higher COP because the water have a higher temperature than if you go out in the river or in lakes or whatever. Yeah.
Thank you. Very good to hear that Brussels is getting on board this agenda, and hopefully it will come together with a revision of the Urban Wastewater Directive. But if it gets there, we will have then an overall integrated target for water and energy. What do you think that will require from the enforcement level? Because today we have public authorities who have only partial responsibility. Yeah. And no one has full responsibility across water and energy. In many countries, they don't even have the full responsibility for water, but maybe only for water supply or wastewater or for water quality. So at the enforcement level, then what?
Henrik, it is a problem. As I have seen in US, where I see facilities getting to 100%, and then they are not allowed to do anymore. There's simply a limit on they are not allowed to be an energy producer. That's not their purpose in life. And that's the silos which we need to break. That's the one thing. The other thing is that we see that there is punishment on that if you produce too much energy, and it's not the intention. That happened in Denmark, for instance. We have had a tax system which certainly not is in favor of utilizing all this energy here. We are changing it now, but it's a slow process. And I can only agree with you that we need to break these silos and we need to look at how can we motivate instead of securing that people don't do anything, because from a climate point of view, from an energy point of view, this is the right thing to do. I forgot, in fact, to say that the return on investment on the case I showed here was on the process side. Process regulation was around about 3 years, and on all what they have done is 4.5 years. So it's not just trying to be green; it's good investment.
And here you almost opened the door for the key premise that the pricing has to be right in order to promote these solutions, and the fencing of the economy of the utility has to be in a place where they actually keep the benefit, so that if they make savings, these savings don't go away from the utility, because then they don't have the incentives either.
But like what I think is super important is that you're right in these points, but they don't need to have government money to do it. It is in itself a good investment. And somebody also believed that now I show a case from Denmark and everything is expensive in Denmark. One thing is not expensive in Denmark, that's electricity. That is in fact cheap. Cheaper than in China. In Germany, it's 40% more expensive. In Italy, it's double price on the electricity for industrial, which means that the return on investment will be even faster in Germany and in Italy and in California, I can tell you. So everything is there.
Excellent conclusion, Mads. And that also means that you almost passed on the baton to Italy. Before we get to Riccardo Panciolini from Italy, we will have a presentation from João Mugueiro from Portugal. Mads, thank you very much. Please stay with us for the roundtable. João, over to you and your also fast forward presentation. Please go ahead.
Hi, everyone. Good morning, Europe. Good afternoon, China. Thank you for this opportunity and for your time and attention. And a special thanks to Liam Gia for the help on translation. I'll be presenting in English, but the insights are also in Chinese language, so it will be easier to understand. My name is João Mugueiro. I'm a water expert and business developer for utilities at Wakaru, and I will be presenting Waterwise System to help water utilities reducing the carbon footprint. At Wakaru, we've been working with artificial intelligence, machine learning, predictive models, algorithms in order to help utilities to be more efficient, from abstraction up to distribution, down to consumption and wastewater in a demand-driven mode in real time, thus reducing the need for fresh water and with a great impact, a positive impact on carbon footprint. We have a team of 35 people, and this year we expect to have 2 million in sales and about 300K in EBITDA. We are very focused on water energy nexus, and this is also why we've been recognized to be suitable in the practice of innovation and R&D for water and energy sectors. And why did we develop the Waterwise system? Because of this, there is this challenge, the water scarcity. So many people will face potable water scarcity and already are, and at the same time, there will be a risk of global underwater wells going dry. On the other hand, we know that water utilities also face really high levels of real water losses. And on the other hand, again, we know that there will be a really increase of water consumption. So what we did was to develop Waterwise system, which already was recognized by the Water Global Practice of World Bank as one of the most innovative worldwide solutions for water networks management, and also for the Portuguese Energy Agency with an honorable mention on interoperability. This is the adoption cycle for Waterwise system. First, we have to measure. So we have to monitor and to meter what's going on in the water networks, either potable water, wastewater, rainwater, and other systems that the water companies need to tackle with. Then we can move on to automation and use on a demand-driven mode and in real-time information what to do in water networks to be more efficient. And then, of course, having a 360 degrees view of the urban water cycle, we can bring from data knowledge and more intelligence to these all operations. What differentiates us is that we get information, we get data from already deployed systems. So we don't have to destroy investments or to put more money on the water networks. We get information for whatever systems may be already deployed, and getting that data and transforming it into knowledge to have actionable insights for the operations. So working with the artificial intelligence and machine learning, we have analytical and predictive models, and on a demand-driven mode, identifying what you are expected to find from the consumption point of view, from the last mile on the system, and then you will have only to produce the amount of water, only to treat, only to abstract and distribute the amount of water needed, and not running business as usual. And by doing this, we all know that water is energy. So if you are more efficient on using fresh water, we will be more efficient on energy consumption, and thus we will be able to reduce the carbon footprint. As we heard in previous presentations, there's a lot to do, and not only in the fresh water side of the urban water cycle, but also in the wastewater treatment plants. But we can do it already. We can look at the information that we get from the sensing existing in the water networks, extract knowledge from that, and be more efficient and be faster on operating and acting over leaks and losses in the water network. So if you need less water because you are being more efficiently running your water networks, you will be using less energy, and that's being more close to a net zero carbon footprint. So with Waterwise system, we monitor seamlessly flow and pressure, energy and water quality, and of course the water energy nexus, okay? We analyze the networks in real time, and we make inferences and predictions in order to understand what is about to happen. So this way, we can get an integrated vision of the urban water cycle. And as we said, with machine learning and deep learning models, we will work with an event-driven paradigm and will be more efficient, more getting more insight information from data existing that we collect directly from SCADAs and directly from IoT devices. These are some of the dashboards that we get in Waterwise System. You can get information on a DMA analysis. We can get the water balance. We can also get the information on the energy consumption if you want an energy balance of what's happening in the water networks. Also identifying abnormal events and analytics, either geoanalytics or operational analytics. And as I was saying, water is energy. So if you reduce water losses, you reduce the need for water, we will be also reducing the energy consumption and thus reducing carbon. Just for having some more insight on this, using information from what happened in 2019 regarding real water losses in Portugal, we had about 150 million cubic meters of real water losses, corresponding to about 150 million kilowatts per hour energy consumption, equivalent to about 43,000 tons of carbon emissions. So we really have to tackle this challenge of, from one side, you have water scarcity, from the other side, you have water wastage, you have increasing needs for water, and we have increasing needs for reducing carbon. So we really have to work on reducing water losses. And for that, you need to understand better what's happening in your urban water cycle. In your company, you have the data, you have to work with that. And that's why we've developed Waterwise System. Thank you so much for your attention.
Thank you very much, Joao. I'm a huge fan of these integrated system approaches as you presented here.
Thank you.
But they also challenge the utilities. Do all your utilities have the necessary capacity, competences? Do we have enough people who can actually deal with these type of systems and managerial setup?
Well, that's a good question. Actually, we know that around the world, and each country have different levels of maturity for each type of water companies. You have private operators, you have public operators, you have small operators, bigger operators, you have more digitalized water networks in some places than in others. But what I can say is that it's worth doing, okay? Because sometimes we are looking about building or preparing a new dam to abstract water from nature when you are not working on the other side of the network. Am I being efficient running it? What's the level of the real water losses that I have? So you just have to, install flow meters, pressure sensors, information that you are getting from the network today. You are not working with it. And sometimes you don't have data. Sometimes you have millions of data that you can work with. So you must use systems. Today, please use artificial intelligence-based systems to extract knowledge from this information. In fact, in Portugal, for instance, you have small water municipalities, small municipalities running water networks. They have around 2,500 customers or 5,000 customers. So it's really small. They don't have this sensing in the networks, but it's cheaper than buying water from another company, okay? Or from building a new abstraction to get more fresh water. So I would say that depending on the level of maturity for each water company, it's more or less easy to do. With Waterwise System, you can work with 10 sensors or with 10,000 sensors. So you don't have to have all the network sectorized and sensorized to extract information and work with to tackle these issues relating water scarcity and real water losses. And of course, the energy side of the business and reducing water carbon. Excellent,
João. I will already now invite you to be part of our webinar series on rural water, which we will launch this autumn.
Yeah, irrigation is also important. And as you all know, rural water is the biggest slice of the cake. So we must do it the right way.
Excellent. That will be our next topic. Still, we are on urban water, and we are on one more speaker before we will get back to João and the other ones during the roundtable. So thank you, João. And
thank you.
On to Riccardo Panciolini from CRB Unigas, Italy. Riccardo, please take the floor.
Yes, can you hear me, Eric?
Yes, we can hear you.
Okay, try to share the screen. Sorry.
And it's there. Go ahead.
Okay, thank you. Thank you to all, and thank you for the invitation. It's a pleasure to be here. And just a quick view of our company, CRB Unigas. Now we changed the argument because we speak about the flames, not the waters, but it's even in the efficiency sector. So sorry. Okay, this is our company. So you can see the path line here. The times the company was founded in '72 by my father, and he passed unfortunately away last year. But we are still a family company. And yes, you see the changing on the name, but our focus was at the beginning and still now the burners. So we are burner makers, and we're working all over the world. And you can see here the path line of time, and we just to simplify how was our development about the emission. We are speaking about the NOx level. That is one of the most important argument in these recent times. So we started with the high value, 150 milligrams per kilowatt hour, and now we are less than 30. So in the last times, in the recent times, we have big opportunity in China market, especially to sell our burners, because to sell our burners and makes some plants to replace big plants, even all the coal burners plants with the new natural gas burners with very strict limitation for emission of NOx. And just to give you some numbers, we are 200 employers over the world. We have substructure over the world. We have our office in China, and our subsidiaries in Russia, UK, and our headquarters is in Italy. And mostly we have export because we sold abroad. More than 80% of our burners going outside, and especially in China market, because it's our second market, so it's very important. And here you can see what is the improvement about the power burnt, so the size of the burners especially. So you can see from the start till 2012 we reached more than 70 megawatt and of power burnt, and the range of the burner is for all types of functionality. So we can use a burner for gas, for oil, for heavy oil, for biogas, for hydrogen, special application, solid fuel even, so coal dust or wooden dust. We can cover all kind of application. And now I want just to talk about a new product. Is a patented product. Is a special product because is just a system. It's not only burners. It's a philosophy, new philosophy of burners, we can say, because it's called facile. Facile word is means easy in English. Facile Italian word, because is a system that can auto-regulate itself on the plant, and it can keep the maximum efficiency of combustion during the operation without changing something on the plant, because at the moment the technology can make it easy if you take some control, electronic control, but you have to use the O2 trim control from the chimney, for example. You have to use complicated system, expensive system. With our system, it's possible to have the electronic combustions without a probe on the chimney, using a special sensor that can feel the flow ahead. And I will show you later a drawing to clarify something. So doesn't matter which is the plant, where is the plant, if it's a higher level or if it's a sea level. So if changing some environmental conditions, for example, the pressure of air, the temperature of air, the pressure of gas, because it can auto-adapt itself on the plant and recognize all the difference and can auto-adjust itself to make the best combustions at the first ignition, and to keep it along on the seasonal changing. And so this can save a lot of CO2 at the end, and can save a lot of consumptions in terms of electricity and gas consumptions. And very smart function is this, for example. So the system can make what the technician have to make on the plant when they make the commissioning of the burner. So it's just enough for the technician to see what's happening on the plant, to supervise the system till it finishes the calibration setting, and the calibration setting during around 10 minutes. In this 10 minutes, the system can auto-adapt itself the position of the actuators of gas and air to create the best performance curve ratio between air and gas, and with the best performance at the emissions. That means the emission levels on the chimney, without a probe, without a closed chain control. How is possible to do it? Because there are some flow curve inside of the memory of the device, the mind of the control, that we made here in our lab for each model. And on the plant, the system can find the position of the actuators in according to the mass flow curve, in according to the calorific value of the gas, and so on. In the automated way. There are not systems that can do it at the moment, the world. So it's very simple. It's simple and also safe, because we have some retroactive system as a feedback from the actuators to see if the correspondence of the signal of the sensor And you can see here a little sketch about the system transparency. We have the burner, so the combustion head, the fan, and the BMS, that is the mind of the control. There are two sensors, one for air and one for gas, directly connected with BMS, and the actuators with the feedback going through the BMS even. And we can control the actuators based on the sensor feedback. So we felt the sensor felt which is the flow that passing through it, and the system can adapt the position of the actuators immediately to guarantee the best ratio between flow of the gas flow and the air flow. We can even connect the boiler probe directly to BMS because we have a modulator integrated on the BMS. You can see here. So we can use an internal load controller with a PID function inside, and it is possible to change these parameters to have the best setting and to choose the set point, for example, temperature or pressure of the boiler. It depends if it's steam boilers or hot water boilers. And the actuators can follow the position, and it's just enough to put the probe from the boilers. Or we can use the external load controller. We can use a Modbus connection, so we can send all the data from the PLC, for example. We have an open term connection to use master slave, several burners in cascade. We can use some signal, so for 220, 0 to 10 generic signal. We can upset other probes. And very important, we can use yes, inverter, and this can save a lot of energy because, you know, if the fan can modulate the velocity, we can save a lot of energy, of course, and increase the modulation ratio.
Ricardo, could you move to the to the cases because we need to go to the round table?
Okay, I go faster. Okay, just to see what we can have from the device to the operator. We can see this as a screen on which we can see the power burn, for example, and the feedback of temperature and pressure. Just for starting the burners, it's just enough to put some extraction, so it's very fast. And as I told before, 10 minutes around, we have the complete setting of the burners. With this burner, we can achieve less than 30 milligram for metric cubic meters. And we can say that can do also an upgrade kit of the old burner to revamp it. And important function is a supervision by remote. So it's possible to supervise all the burners by a platform, special platform, on which is possible to see the place, the service, and the model. We can have the geolocalization on the maps, and we can see by remote what's happening in each burner. So the power burn, the position of actuator, the flows, the alarm, the flame presence, and so on. We can even have the predictive assistance. So we can put, for example, the email address here, and the burner can advise me if something going wrong, and so on. We can storage the curve, the regulation curve, for more than 10 hours of working the burners. So at the end is a very smart system, can keep the O2 level at the same value even if a change in the environmental condition, the working field is auto-adaptive, basing of the condition of the plant, with self-learning ignition point, self-learning servo motor settings, and self-checking air gas ratio. At the moment, the solution can guarantee the range from 200 kilowatt up to 12 megawatt. And we are working to push the product on China this year, and we will see what's happening. Okay, we go faster at the end, but finish.
Thank you very much, Ricardo.
Okay,
I will now invite the speakers, Tia, Jingjing, Jingchuan, Mads, Joao, and Ricardo to join me for the roundtable. And I think, Ricardo, you need to close your presentation.
Yes, sir. Okay.
Excellent. So for the roundtable, I would like to start each of you briefly, just to say what has been your main takeaway from the discussions today, and I'll particularly like you to reflect towards the constraints which I showed in my opening presentation. I will ask you, and as I see the sequence on my screen, Jingjing, briefly, what has been your main takeaway?
Our takeaway will be in the last 12 years, China has been 50% growth in wastewater treatment facilities scale, and also the power consumption per unit, and also the greenhouse gas per unit has been dramatically linear growth corresponding with the wastewater treatment amount. And this is what we can keep forcing the growth in the rural wastewater development in the coming 10 years.
Thank you. Tia?
Yes, I'm happy to see that our ideas in the white paper are actually the same thoughts that presentators here had. So we are all on the same page with the problems.
Okay, Joao?
Well, I would say that it seems that already everyone already knows where we are, what problems we are facing. How these problems grown within the last years. It seems that we already also know that there are solutions, okay, some of them easier to install than others, but most of all what I felt is, this is also something that Henrik has already mentioned, is that we need regulators to push this and to make it happen. So we have a problem and we know which is the problem. We have the solutions, okay? We can implement those solutions. Probably we just need to be obliged to do that. So I think that's what I'm taking off these presentations we've solved. Thank you.
Okay, Jingshuan? Jingshuan Lu, just turn on your mic.
Yes. I'm happy to participate today. I think it's very good that we can use the China EU Water platform, and we have so many colleagues can work together. And it's our opinion that we have to organize the company together to provide solutions to adapt to the Chinese conditions. We do think that's the best way to set up cooperation in the water sector between Europe and China.
Thank you, Mads.
Yeah, but I think more or less we have covered when we had our chat, Henrik, that what I really take away once again is that it shows that we in fact have the technology, we know what can be done. We don't need to rebuild all existing facilities. We can upgrade the existing one. But the motivation need to be there, and the motivation in the water industry is quite often a question about the regulative body, whether there's some regulation pushing on it or there's some motivation in one or another way. And then I think also that my learnings, at least from US and from Europe, is that as you also indicated, when you begin to work with these things, you'll also find some silos where you are not allowed to be an energy producer and all these things, which you need to kill. We need to kill them anyhow for a lot of other reasons. So I think we will have to deal with that anyhow. But I think that's a cornerstone in find a solution there. If we don't do that, the industry will not move forward in the speed we need. So
okay,
yeah.
Thank you, Ricardo. Your main takeaway?
Yes, I fully agree of what they said, and I think the technology now is ready, has a good standard to solve some problems. So if the legislation can help the industry to introduce the best technology, I think we can solve a lot of problems with the collaboration, strong collaboration from the Europe and China. We can strict this collaboration and to improve the emission, the efficiency. We have some solutions, so I can see the green future for all.
The possibilities are there technologically, but still, I mean, are we at a stage, and I'll take the same round again, don't we need more technological innovation? And if we do, where do we need the technological innovation? Or is it more a matter about adapting current solutions to small scale? Jing.
I think when we start about this, looking for the database to elaborate this foundation of this presentation, the most challenges for us is to get the decent data. I have to say it, actually, back to 2015, there is no comprehensive wastewater treatment scale, no matter, even for all these power per unit calculation are based on our own calculations. So I think for just backbeat, like to say, when we don't have a good consistency methodology applying for knowing how much wastewater we have, how much we have treated, in a better way, and then for the rural wastewater, if there's no clear, I think if we don't promote the better decentralized, energy less energy intensive solutions in our enforcement, as us, we can very difficult to see how we can reduce our emission reductions, I think. Yeah.
So without mapping, we can't navigate. Tia.
Yeah.
Yes, I think at the moment we have the technology to solve the problems, but of course, development of new technologies and making existing technologies better is usually a good idea, because the world goes on and the future changes all the time. But what we really need is communication, and as I said earlier in my presentation, mind chains and collaboration, how to make technologies work. We have to use them.
Right now, the next 7-year program for joint European innovation is taking place, Horizon Europe's Water for All partnership, and that one will focus a lot on technological innovation. Joao, you made the Waterwise system, the system to end all systems.
No.
But are we in a situation where we should focus much more on implementation and barriers than actually just developing new solutions?
Clearly, I would say that. I was going to complement the previous comments on your previous question by saying that us as supplier in an open market, okay, have to face this sector. We choose water sector, okay, for the reasons that you already know. We told you, okay, because there's water scarcity, because there is going to be more need for water, because there is water wastage and energy wastage, and because we believe. And saying this, what I mean is we are working in a natural monopoly area, okay? So you don't have competitors. When you are running a water company, no one is going to take you off there and putting other guy, okay? So you are running it, that's yours, it's a monopoly. You can do whatever you want, okay? But this is each time more less true, okay? And you have to believe. Stop making pilots, stop making proofs of concept, just implement it, test it, let's go. Because things are there, technology is there, digital solutions are there. I could say Waterwise System is the best one in the world, but there are so many. Just try, implement it. Don't be afraid. Believe that we can do better, okay? We know what we are doing, okay? We tested it, okay? We tested with databases, real databases. So let's just go forward. Don't start and, well, maybe if we can do a pilot in that district metered area with about 100 customers, no, just implement it. And you'll see at the end of the year that you've paid for the system that you are using and you've reduced water wastage, you've reduced energy consumption, and you are doing better with digital solutions and with the technology available. It's not the same thing all around the world, we know. You can do it differently in the US, in the UK, in Africa, in China. It's a little bit different, but the main information, the main developments, the main technology, it's there. You can use it. Water is water around the world.
Jingchuan, you're in dialogue with a lot of utilities. As Joao said, just do it. Or do they still lack some incentives, some framework to just do it?
I do agree with Joao. I think we need to implementation instead of promoting the concept. I do think we have enough technology in Europe. In Denmark, we have a lot of advanced technology which can be used in China for the time being. It's a good opportunity. China just has a goal of 30, 60 year carbon goal, climate goal, right? It's the right time for us to bring technology to China. But I think we do need to integrate the solution together. Before we work with the Chinese partners, we need to take care of the Chinese partner also, because it is a market activity. We have to make a good business model to make project instead of a communication or a technology exchange. It wouldn't create a project. Sometimes when we talk with the Chinese partners, they do asking for what we can buy from you. Single equipment cannot solve the problem. We have to provide solutions to help them to solve the problems, to solve the challenges. Then they can benefit to work with us. Otherwise, it will not create any business or project. That's my opinion. Okay. We need to have enough in Europe.
Mads, well, it's a bit going in circles. The water problems are immense. Water is super important to society. Solutions are here. Just go and do it. But something is the key constraint. Is the key constraint the water sector actors have not been good enough at telling this comprehensive story in a simple manner? Do we need to put our message more clear and more convincing?
I think it's part of the game. As reflecting a little bit on your question, whether we need new technology or not, I think we always need to develop ourselves. But I'm sure that if we could get the market to move, you would see the new technology we maybe are lacking. You'll see that coming very fast. So I'm not so concerned about that. I'm mainly concerned about implementing the technology we already have, and for sure. There the issue is, as you rightly point out, what is the motivation? Part of that is, of course, to make people aware and talk in a simple language, as you also indicate a little bit. What can get the political people saying, hey, this is great. Also, some of the figures we had here, and I spoke about some figures in Denmark where we can heat 20% of all houses in Denmark. Now, suddenly I have some political guys who listen to me, where if I go too deep technical into Danification, they don't know what I'm talking about. Yeah. So that's part of it, to provide the political environment, which have the pressure. We heard that also from China, to reduce the CO2 or mitigate the climate issues. So it's a question about making aware that the water business have the capability to be a major contributor to this overall issue about climate mitigation. And that way, hopefully, get somebody of the political environment to set the right rules and to tear down some of these walls they have put up, which in a new world where if you look, as I say, I had a slide of sustainable cities. There you'll see that everything on the energy side is interconnected, and that's the only way you can do it. Everybody seems to agree upon that. Now, if that ever should fly, you need to tear down these walls between who is producing energy and who is providing water and la. I'm sure that's the way forward. More awareness, simple communication on political level, get the political guys to set some frames and tear down some walls. Yeah.
And a lot of vested interests have to be put aside.
Yeah.
Ricardo, a technology question for you before I go to a concluding round for final remarks for each of you. Some of your solutions have a broad range of capacity from a few kilowatts to several megawatts, if I recall right. Do you receive the same attention from, let's call it, small scale sites as and for the low end of effect of your solutions, or compared to the large scale users? Or is there a bias that the ladders are more ready and the first ones maybe still lack something?
Yes, I can see that the solution in technical way going to promote different system for the low capacity. It means about electronic pump, heating pump, or electronic system instead of burners. So the focus of the burners from now and especially for the future is to improve the new technology for the medium, bigger size. So I think this system could be proposed especially starting from 200 kilowatt up to some megawatts, even more than 10, because we are ready to go up to 12 megawatt at the moment. But the important point is to connect these systems with really good combustion system that can permit to use, for example, hydrogen mixture, because now in Europe especially, we are speaking about the possibility to use hydrogen on the net, the gas net, to create blending between methane, natural gas, and hydrogen with several steps that can be possible to, at the end, at 2030, to achieve around 20% of hydrogen in the mixture and burn it very safety. So I think it's very trustable, for example, to create some kind of integration to various systems, to, for example, to integrate the burners and the heating system in a green way. So produce hydrogen, for example, with electrolyzer by the photovoltaic cell, and take it in the buffer and make a blending with the natural gas and burn it. So it's very important this next step. So produce to be able to produce green hydrogen from renewable technology and burn it directly on the place.
Okay, thank you very much, Ricardo. Before we have the intervention from Lian Jia and talking about our upcoming events at Aquatech Shanghai, I'll ask for if you have a final remark, final takeaway from the event. Jing Ma, please.
Sorry, can you say it again?
Do you have a final remark for the roundtable? A very brief final remark.
Final remark is that we can see the potential huge growth for the rural wastewater, and we also would like to the key influential player to make the government put on the more like nature-based solution, and also the energy, much low energy intensive equipment like the MBBR solutions, or more like biological treatment instead of mechanical treatment, because compared with urban development, rural has been requiring much less, should use much less energy intensity mechanical treatment instead of compared with the urban. So this is what we would like to suggest for the Chinese, the reduced emissions for the future. Yeah.
Excellent. And as I have mentioned, we are going to have a webinar series on rural water this autumn. So all ideas for topics are very welcome indeed. Tia, your final remark.
My final remark is, well, we have the same problems. The technology to solve the problems exists, and now we have to somehow use it, and we need some kind of guidance on regulation, laws, and make it profitable and provide package solutions.
Okay, João, final remark.
Well, they are written here, as you see, so no to change. We already know, and now we have to change. We should do it step by step, and definitely we really need authorities, regulation, and we need public awareness. But most of all, I would say we need political insight, and most of municipalities, water municipalities, and wastewater municipalities are public companies. Okay, they're not public companies; they are public entities. So I would say that, as Mads was saying, we really need politic push to do this right.
Excellent, João. Jingchuan, final remark from you.
Thank you. We have been working with a lot of Chinese water companies, but it's also applying to work with the local authorities, the water authorities in the municipalities. I want to know to what extent CWT could reach the central government authorities like environment ministry or water ministry. To what extent we can connect them, to influence them.
Yeah, and the very quick answer is that's precisely what the platform is about, to have discussions about the water sector developments, and then actually bring this to the central levels. So what we will do is we will based on all the webinars and events, we will make a concluding report and we'll present the conclusions. Hopefully we will be able to present them both high level at Water Resource Ministry, Environment and Ecology Ministry, but hopefully, actually my ambition is also, if possible, to bring this to NDRC as well.
Yeah, good, great, thank you very much.
Mads, final remark.
Yeah, but I think that have just been said, because I would in fact push back on you with all your good connections. Could you not get somebody moving? So I think that was my comment. Not more.
Yeah, and that's my job. So it's taken. Ricardo, you'll get the final brief remark before we pass on the floor to Liam Jia.
Oh, thank you. So no, I think that is we have the technology, so it's not a matter of if, but when is possible to introduce strongly in the market. So, and for this is very important to government legislation and support. So the coordination with the company, and because I think the standard technology level now is trustable, is high. So we are ready to participate at this new job, and I think will be soon.
Excellent, Ricardo.
So,
thank you all for your active involvement here with your very interesting presentations and discussions at the roundtable. We will now pass on the floor to Liam Jia for the final remarks. And Liam, I will also ask you to conclude the webinar. So you will, it will not go back to me, but you will have the floor from here and tell us about what will happen at Aquatech Shanghai. Liam Jia, please.
Thank you, Henrik. Can you hear me?
Yes.
Okay. Thank you very much for, as well, to all the speakers for sharing the insights. My name is Liam Jia. I work for the EU SME Centre in China. We are a European funded project providing support for small and medium-sized enterprises in market access to China. I prepared a very little slide that I will share with you. This is the fourth webinar that we organize in collaboration with China Europe Water Platform in this year. And throughout these four webinars, we have had many interesting speakers, many different types of stakeholders participating. And finally, we are coming to the last one. And we are also going to continue our discussion at the Aquatech in Shanghai this year in June, from the 2nd to the 4th. Taking the advantage of being physically in China, we are able to participate physically at the Aquatech in Shanghai, where we are also going to represent China Europe Water Platform by having these two seminars organized, one of them focusing on digitalization of the water sector, the other one on circular economy and everything around this topic of the water sector in China. At the meantime, we are also going to have the opportunity to already consolidate all the four outcome reports of the four webinars that we have organized into one report, and to have this presented during these two seminars and raise this discussion around the outcomes. At the same time, we're also going to have a physical setup, a small booth at the Aquatech, and several activities will be organized at the booth as well. That includes one-on-one consultation with the exhibitors on market access. As well, we are very happy to have our sister project, IP SME Help Desk, one of the IP advisors of the IP Help Desk will also join us at the booth, who is able to provide the exhibitors on consultations on IPR protection. All these services we're offering free of charge for exhibitors. As well, we will be able to connect with all the participants online. And also, I extend this invitation to our panelists and speakers participating in this session. More information we will be sharing through ours and also the channels of China-Europe Water Platform in the coming days. We are 2 weeks already from Aquatech in Shanghai, and still we are trying to collect interest from businesses who are willing to engage further with us at the EU SME Centre and also at the China-Europe Water Platform. I am not sure, Henrik, if you still have anything to add. Otherwise, I would like to thank again everybody for your participation. And then hopefully we'll see you at the next seminars and webinars at the Aquatech in Shanghai. Thank you.
Thank you, and this was the end of the webinar. Thank you.
Thank you.
Thank you.
Yep.